Okay, everyone, we're going to look at surface area of cylinders. I'm also going to just do a quick thing about volume with you as well, just to kind of review. So volume and surface area of cylinders. Okay, so if you have a cylinder, you know it's got something that looks similar to this. Okay, basically the top and the bottom of the cylinder. So think of a can of soup, right? You have one circle, and then you have another circle, which is going to go off of the page, and then that's actually connected by a rectangle. Okay, and this isn't a very good drawing of a net, but if you can sort of visualize, we've all seen cans of things and they all have labels. So you can visualize that label, and I don't know if you've ever had to peel the label off, if your family's asked you to do that as part of recycling, I don't know. Or if you've ever seen somebody else just do it, you know that that label is a rectangle, okay? So we're going to go to the next slide. Okay, so in order to find the volume of a cylinder, or any right prism for that matter, you always look at, so I do this universal formula of the area of the base multiplied by how tall it is, its height. So this works for any, as I said, right prism. So if I had a rectangular base prism, I would know that the area of the base I can find by length times width, and then I just multiply it by height. So that's the volume of a rectangular prism. I'm not going to put that there. Let's just erase that. So the volume of, we'll say, rectangular prism is length, width, height. If we have the volume of a triangular base prism, okay, we have to think if this is the face and these are my other faces, right? But these are the main, that's the base. And then you have that congruent base at the end. We're finding the area of, and I'll color this one in, area of this guy. Okay, and then we want to multiply by its height. And I know that looks like a length because we've got that rectangular prism sort of laying on its back, right? But if it was standing up, it would be the area of the base times the height, right? For a triangular prism, I have that triangle, and then I have three of these two triangular bases or faces, and then three rectangular faces. So this would be what I would consider in my volume as the base, and then I would multiply it. I'd find the area of that base, the green part, and I would multiply it by how tall it is, or how long it is, however you want to look at it. So I know that the formula for finding the area of a triangle is base times height over 2, and I can multiply that by, you don't want to use base again, right? Because you know from algebra that it's algebra means that your variables have to have the same value whenever you use them in the same equation, so, or expression. So we don't want to have base times height over 2 times base, because this is basically your base, right? So we want to call this maybe the length, okay? Or you could say, yeah, you could do that. Length or depth, it could be times d. So with a cylinder, go to the next page, Now we have our cylinder again. Excuse my drawings. Okay, and the two congruent faces on the cylinder are here and here. So from a volume perspective, we want to find the volume of a cylinder, and we know that it's area of base times height. Okay, so that's my universal formula for volume. So the volume of a cylinder, I need the area of the base. To get the area of a circle, it's pi r squared, and I'm going to multiply it by the height. Okay, and then this drills down to pi times radius, because that's not radius times 2, remember, times height. Okay, for those of you that need to see that a little bit more expanded, that's what it looks like. Okay, so if I came in and I told you, hey, this thing here, so this has a radius of 5 centimeters, for example, I'm going to pop in all of my values. So I'm going to say 3.14 times, and then if my radius is 5, I'm going to come in and use that radius value, okay, times height. Oh, I didn't tell you the height. I'm sorry. Just going to go back a little bit. Let's say that the height here is 10 centimeters. Okay, so my little can is 10 centimeters tall, and we're going to say this is times 10. Okay, so now what we want to do is calculate all this out. So I could do this in any order, right? Because I'm multiplying, multiplying, and multiplying. So I'm going to do some mental math before I calculate. 5 times 5 I know is 25. Okay, and then I can do some more mental math. Some of you might be able to do that in your head. I cannot. Is multiplied by 250. So first I multiplied the 5 times 5, and then I multiplied the answer, which is 25, by 10. And now I've got to do the 3.14 multiplied by 250 is going to give me 785. So remember, in order to find area gives you squared units, so cm squared, meters squared, but now we're dealing with volume, and that's a cm times a cm times a cm. So now we have a cm cubed, and we have meters cubed. So we're dealing with cubic units. So this is in centimeters, so we have to say centimeters cubed. Okay, so now let's get to the tricky stuff. Area. Okay, I always just say SA, but it's surface area. And when you're dealing with surface area, I want you to think of wrapping a present. Okay, so the surface area is that outside, you're sort of measuring all the individual areas of all of the faces of whatever that 3D shape is, and then essentially adding them all together. And sometimes the formula combines certain things if you know you have congruent faces. Otherwise, you could do it all separately. It's however you come about working on it. So we know that we've got this net, and that's of our cylinder. Okay, so that looks like this guy. And again, if I want to say that I have a radius of 5, okay, that's my radius there, so that's going to equal 5. And I know that that label on my can is, what did I say, it was 10 centimeters high. So we have to determine, and some of you are visual and some of you aren't, but remember, up here and up here are your circles. So those are the top and the bottom of the can. And the top of the can is attached to that long portion of the cylinder. the height is actually the same as this, because if we were to take that label and cut it or rip it, you know how they're sometimes overlapped on soup cans and things. Sometimes they come off because the glue's all wrecked. But either way, that's where the height is. Okay, so this is the height. So this is your 10 centimeter value. Except we have a problem because surface area means that we're going to take the area of the circles and think how many you have. Okay, so we have area of one circle, we have area of a second circle. You should know that those two are congruent, so you could also just circle times 2. But we have to add those two together, but then we also need to add it to the area of the rectangle. And here is the problem. If we just isolate the area of the rectangle, this here, I'm doing it in red on purpose, you know the height, but do you know the width of that triangle? Or the width of that rectangle? So when I say width, I mean this actual. Okay, we know how tall it is, so we could talk about length, whatever. But we do not know this part. Okay, so what we want to do is we want to figure out how can I get that part. So there's one extra step. And I'm going to quickly draw these again. Okay, so we've got our cylinder here, this, that, that. Okay, so we already know that our circles, we can find circle equals pi r squared. And we're going to times by 2 because there's 2 circles. Our rectangle equals, we can say length times width. Okay. Our length, we've already established we don't know because that's this value. And then the width is technically the height of that label, right? So this could be our width, but we've got to find this whole thing now, and we're missing one of the dimensions. So we know this, but we don't know the other one. So what I want you to kind of look at, and maybe it means going into your parents' into the pantry, like where you keep cans of soup and things, but unfortunately we can't investigate this at home or at school, so you have to do it at home. But if you were to take off that label, you will notice that this top longer part of that label, in this case anyways, is the same as the distance around that guy, right? Because in order for you to go all the way around the can, think about a can opener. If you go all the way around the can with a can opener, you're going from this point all the way around and then stopping again, because then you're able to open it. So the length of that rectangle is equal to the circumference of the circle. So it's a nice long formula, but I'm going to shorten it, or I'm going to explain it to you in formula way right now. Okay, so we're going to go back again. Trying to do this slow because it's tricky. Okay, so we've got this. We've got a radius of 5, and we've got a height of 10. And we know that the surface area of a cylinder equals 2 circles that have a value of pi r squared multiplied by pi times diameter, which is this equals circumference, okay, pi diameter equals circumference, but we have to also times it by the height of the cylinder, because we need that value, and then we also need that distance around. Okay, so the other way you could do it if you have the radius like we do is call it 2 pi r squared, so those are my circles again, times 2 times pi times radius, because that also gives you the circumference, times height. So you get to kind of pick and choose. Okay, so we're going to do it with, I guess, the 2 pi r h. I need more room. And I need more practice with my drawing my cylinders, right? So hopefully I'm getting better at this. So this is my circumference. That's my can. It has a height of 10 centimeters. The radius of the can, radius equals 5 centimeters. Okay, and we're going to use the surface area equals 2 circles, so 2 pi r squared plus 2 pi r, because that's my circumference, times height. And now we got to substitute everything in, so this is going to get long. Okay, the first thing I'm going to do is plug in all of my values. So 2, I'm going to put a dot here just instead of brackets, so that's 2 times 3.14 times my radius is 5 squared plus 2 times 3.14 times the radius is 5 and the height is 10. I squished it in. And now we just have to simplify. So I know that 2 times 3.14 is equal to 6.28. And I'm going to multiply that. Again, I'm going to do the little dots there for you. 5 squared is not 5 times 2, it's 5 times itself, so that gives me 25. And I'm going to add that to 2 times 3.14 is 6.28 again. And then the bottom here says 5 times 10. Well, I know that's going to be 50. Okay, so now I've got 6.28 times 25 plus 6.28 times 50. So please remember that you can't do certain things until you've got everything simplified. So right now we're multiplying on the left side of the adding sign and we're multiplying on the right side of the adding sign. So I'm doing it all at the same time, but as long as it doesn't interfere with that plus sign, we're okay. So 6.28 times 25 is 157. 157. And we're going to add that to 625 times 50, which is 314, which is double what that is, right? 314. And then we just have to add those two together and we're done. And that would be centimeters. And this says surface area. Okay, so because it's surface area, it's centimeters squared. We're not dealing with the inside at all of the cylinder. You're only dealing with the outside coating of it, the outside wrapping. So word problems, it might ask you how much wrap, how much paint to cover it, what is the surface area of the portion that needs to be painted, for example. And you also have to look out for things like a question might be asking you to wrap a tube, but this side stays open. So kind of like what's the surface area of a toilet roll? So you've got to figure out just this. So now you say, hey, wait a minute, I don't have any circles anymore, so I'm just going to do 2 pi r height, because I'm going to find the circumference of the invisible circles because it's open, and I'm going to multiply it by how tall it is, and that's going to give me that tube. But for now, for practice, I'm just giving you questions that have standard surface area. So see what you can do with it. Come back to this, message me if you need me. Good luck!